All right, so I had some questions on some students who it's not really certain on how to do some of these. So let me log on Google Classroom while we're doing this. Not Google Classroom, but Google Sheets. Oh, sheet. There we go. So what they want you to do in this first one, is they want you to verify using a calculator or software, basically Google Sheets, that the equation, if we would write it, because it's kind of on 2 pages here, the equation is y hat is equal to negative 6.356. I have the book here. Let me get the book. Where is it? Where is it? Where is it? There it is. Plus, oh, okay. Apparently, the question I have is a bit different than what's on here. All right, you might be getting a different question. So this is gonna be fun because if you have a book, huh. Well, it looks like I'm going to have to take a copy of this book anyway because, let's see here. This is not right. I don't know why. I found this online, this book, but apparently this is an updated version or a incorrect version. That's good to know. Because I'm matching this to the book. This is what's in the book, these numbers. But that definitely isn't the equation. Okay? So what I'm going to do instead is I will post a copy of the questions from the book, and hopefully that'll help out with some of your questions because you're probably wondering why you're not getting this equation. So just so I know the equation that they have in the book, we'll write this, is y hat. Oh, I'm right on this. Oh. Is equal to 27.64 plus 0.527. So it looks like I'm just going to delete this version of the book, and I'm going to take photos of the book anyway, because one, this doesn't go very far. The book that I posted online doesn't go far enough, and two, it's apparently incorrect, which is just awesome. Okay. So just to show you that this is the equation, what we're going to do is we're going to put this data into Google Sheets. Okay, so I'm going to move this over here. Let me just make this a little smaller so we can see. All right, so we have brother and sister. So brother. There we go, something. Sister. Oh, come on, why are you going so slow? All right, then we have 71, 68, 66, 67, 70, 71, 77. No, not 71, 77, 71, 70. Why are you going so slow? 70. There we go. 73, 72, 65, and 66. All right. And then sisters would be 69, 64, 65, 63, 65, 62, 65, 64, 60, 60, 66. Come on. Yes, there we go. 66, 59, and 62. All right, so we have all that typed in, and what we're going to do is we are trying to get this equation. We're going to highlight and insert chart. Again, if it's not the first thing that pops up, that's fine. What you want to do is over here, select the correct chart. So if it's not the first thing that pops up, just make sure you go all the way down to scatter and select scatter plot. We don't have to do anything special with this. What I want to do, once I have scatter plot selected, go to customize. So again, hopefully you took notes on this. I don't know if you have your notes, but if you're not, go to customize. Once you insert chart, select scatter plot if it doesn't automatically come up as a scatter plot. Customize and then series. Under series, you're going to see at the bottom trend line, and then under label, you want equation. And there's the equation, 0.527x, and I forgot to write the x there. So let's put that x there. All right, 0.527x plus 27.6. Now again, this is Google Sheets. It doesn't like to, it rounds to whatever it wants to round to. Okay, so unfortunately, that's just the way it's going to work. So I'm not going to stress if you're getting the numbers, if not rounding to whatever they want you to round to. Okay, I don't really care at this point. All right, so that's what they want you to do for the part A. Now part B, minimize this. Part B, now this is still correct for part B, is Damien is 70 inches tall, predict the height of his sister Tanya. Okay, now what that means is they want you to plug in 70 in for X and then just put in your calculator. So you would do this. This is your prediction. So your prediction would be y hat is equal to 27.6. And you just use the one on Google Sheets, that's fine. Plus 0.527 times 70. And you just put this in a calculator. 27.6 plus 0.527 times 70. And get 64.69, or roughly 64.5. Okay, that will be your prediction. So let's see how the rest of these questions go. First one's not starting out too great. All right, let me clear this. So question 17, the measures of water quality, biochemical oxygen demand, or BOD, measures organic pollutants in water by measuring the amount of oxygen consumed in okay, So here's the equation, and that is correct from the book. What does the slope say about the equation? So this is really making sure that you're trying to understand, one, how to identify the slope, and two, what does it mean? What does the slope mean? All right. So the slope is right here. That's the slope. All right. Now, this is really fun to put because this is a really technical setup here: biochemical oxygen demand and total organic carbon. Whatever those actually are, I have no clue. So what this says, what the slope says is, so this is part A, for every increase, well, let's say change, you really want to use the word change. For every, and they go by what? They said it goes by milligrams per liter of water, okay? So to say every milligram, so for every milligram, because that's the unit of measurement, so for every unit of measurement, in this case milligram, change. So every milligram change in TOC, which is total organic carbon, All right. The average change, you want to use the word average, okay, change. That's what slope is. Remember, rate of change. Slope is rate of change. So for every change in one, there should be a change in the other. Okay, so for every unit change or milligram change in TOC, the average change in BOD, which is biochemical oxygen demand, all right, is 1.507 milligrams. Because again, we just use what unit of measurement they're given, which is in milligrams. So that's part A. That's how you would answer every question about how to explain the slope. And again, it's going to be important to understand how to explain the slope. What does it actually mean? Again, the Google Classroom or Google Sheets is going to do the work for us, the calculations. What you have to do is explain it. So, all right, so let's see, part B, what is predicted BOD when TOC is 0? Values of BOD less than 0 are impossible. Why does the prediction give an impossible value? Okay. This is a really good question. So part B. First, they want us to predict when TOC is 0. Basically, when TOC is 0, that is your y-intercept, negative 5.43. All right. Now, question is, it's impossible to have a BOD less than 0. All right, so why does the prediction give you an impossible value? Well, this is, again, you have to understand the concept here, and it's really not great in the way they give this question because it's such a technical question. I don't expect you to know anything about biochemical oxygen demand and total organic carbon because I don't, okay? Guys, Mr. Howe about all this. So yeah. But the reason why the prediction gives us an impossible value is because if BOD less than 0 is impossible, that means that TOC is never going to equal 0. Or, so TOC can never equal 0. Or, another explanation is the data they found this equation, okay, 0 is outside the data set, which means we didn't have any values that were 0 for TOC. Apparently, total organic carbon is never equal to 0. So that means that this is also, that's not a T, that TOC equals 0 is also impossible. So either we are what's called extrapolating, okay, which means we're predicting outside of our data set. And again, they didn't give us a data set, so we'd have no way of doing it. So either we're extrapolating or this is impossible. So that's why the prediction gives us an impossible value, because the setup is impossible or they're doing something incorrect. Okay? Again, yeah, I can understand being difficult to answer. All right. Let's see here. 19. All right, data set looks good, so I think this question's fine. Let me hear a second, right? Sarah's parents are concerned that she seems short for her age. The doctor has the following record of Sarah's height. Make a scatter plot of the data, note the strong linear pattern, use the calculator to find the equation, least squared regression line, blah, blah. Predict her height at 40 months, okay, and at 60 months, and use your results to draw a regression line on your scatter plot. What is the rate of growth? That will be the slope of your equation in centimeters per month. Normally, growing girls gain about 6 centimeters in height between ages 48 months and 60 months. What is the rate of growth in centimeters per... Oh, sorry. Sarah growing more slowly than normal. So here they want you to find the slope between these two. They gain about 6 centimeters between 12 months. So that's basically half a centimeter a month. So is Sarah's growth more or less than half a centimeter a month? All right, so first thing we got to do is make the scatter plot. So let me open Google Sheets. I don't really need the drawing tool for this. So Google Sheets, I'm going to delete this. Delete all that. So we have age and height. So we have, put the data in, 36, 48, 51, 54, 57, 60. All right, now these are in months. Okay, and then we have 86, there we go. 86, 90, 91, 93, 94, 95. All right, so let's go ahead and insert our scatter plot. Again, the whole thing is we have to do the scatter plot. So insert chart again. And again, it should come up as a scatter plot here. But if it doesn't, we go up to chart type and select scatter plot. Okay. So customize, we want to include the series, and under series the bottom trend line, and then scroll down to the bottom again and label as use equation. So that's what we wanted, is the equation. Now, again, this isn't the way the book likes to answer things. They like to answer it backwards. And what I mean by is this, they want you to write this equation as y, give me a second. This pen tool is new, and I keep making some mistakes on that, and I'm going to keep doing that. It's not going to change. So y hat is equal to 72 plus 0.383 times x. So this is the slope. All right. And let's see here. We get, which means 0.383. So looking at the rest of this, all the questions that we have. All right, it goes. So we have the scatter plot. Okay, we have the we made the regression line, and it says predict a height at 40 months and 60 months, which basically means they want us to do this. And I forgot to do the pen thing again. So y hat equals 72 plus 0.383 times 40, and y hat equals 72. 0.383 times 60. They want us to do both. So, and then the last question is, what is Sarah's rate of growth? That's the slope. That's the rate of growth. All right. Since most, it says growing girls gain about 6 centimeters in height between 4 and 5, that's not half a centimeter. That's a little less. So, yeah, she is growing a little more slowly than normal. Okay. And it's okay to be short, parents. Okay. It's not a big a deal. All right, so let's see here. All right, let's see. So use the least square regression line for the exercise in, okay, basically the same question. Convert it to inches. Okay. Oh no, you answer this one. Okay. By the way, the convert to inches means you need to multiply all these by this rate right here. So you could do that on, let me go to Google Sheets, because you can do that on Google Sheets. Where are you? There you are. I'm gonna delete this. All right. So what I'm gonna do is I'm gonna say height in inches. So height. Actually, I'll just copy age. So Control C, Control V, And then we're going to do height inches. All right. So what I'm going to do is just say this is equal to whatever that prediction or whatever that step was, which was 0.3973 inch. So every centimeter is that much. So I need to divide by that, not multiply. Divide by that. No. Let's see here. Yeah, no, multiply. So I'm going to take these. So I'm going to take equals to this times 0.3937. Was it? Where's that? 37. All right. So I'm going to scroll that down. What that does is it doing this, once you do a little box here, scroll down, it copies the formula. Okay. So she's 4 years old, and about 4 years old right here, and she's about 35 inches tall. So yeah, I could see that being a bit short, because that's less than 3 foot. Okay. Once they get around 5, they really should be a little bit taller than that. 4 or 5, yeah, they should be a little bit taller than that, I think. I wonder what the average height of a 4-year-old would be. Look it up. It really doesn't make a difference. All right. So the question is, convert inches using the centimeters. Have the data have r squared and blah blah. Why is the prediction clearly silly? So predict your age. Oh, at 40 years. At 40 years. Okay. Okay. So I reread this question all wrong, because what they have here is convert your final result by that. So we're going to use that equation we had before. I'm just going to see if I can just that. Oh, there we go. Forward. There's the equation. So I'm going to use the equation and plug in 40 years. Now that is 480 months. So that means I'm going to do this. Let me write this out. So we're going to do y hat is equal to 72 plus 0.383 times 480, which is 72 plus 0.383. 72 plus 0.383 times 480. Now, to be honest, I don't even have to say this, that this is prediction is silly, because do you constantly grow at the same rate from when you're 5 to when you're 40? No, you stop growing, and honestly, even in your teens, you grow differently. As you grow as a child, you grow differently in your teens, and you grow definitely differently beyond your teens, because you tend to stop growing at a point. Okay? So, yeah, it's honestly silly, because one, if I convert this, I get, by the way, I get 255.84 centimeters. Now I'm going to multiply that by 0.3937, and that is 100.72. And being that and divide this by 12, because there's 12 inches in a foot, that's basically saying they're 8 point, oh, where'd that go? He's saying that this is 8.4 feet tall. Okay, I mean, I know she's growing a little short, but yeah, you don't keep growing once you're past a certain age. So yeah, it's silly. It's just silly because you don't grow at the same rate once you reach a certain age. That's all. It's kind of a odd question. You didn't even have to do all that work to really even make that statement. It just should make sense, okay? But they still want you to make a prediction. All right. So all right. Keeping water supplies clean requires regular measurement of levels of pollutants. Measurements are indicated to blah, 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 blah. Is there any chart here? Oh, here's the chart. Okay. So, chemical theory says that data should lie a straight line. the correlation is not at least 0.997, then something went wrong and a calibration procedure is repeated. Plot the data. Must the calibration be done again? All right. Now, basically, they want you to do correlation. Okay, you could do the scatter plot, but you don't need the scatter plot right now. They want you to do correlation. So let me put this on Google Sheets so we can see the correlation being done. Delete these right here. There we go. So we'll just do N and A because I don't want to write the whole thing. I am lazy. So, and again, feel free to do the same. So we have, was it 50, 50, 100, 200, 400, 800, 1200, 1600, 2000. It's not even keeping up with me. 2000. All right, let's put it again. 50, 50, 100, 200. $400. Come on. There we go. All right. Enough of that mess. 7, 7.5, 12.8, 24, 47, 24, 47, 93, 138, 183, 230, and 226. So that's the data. And what we're going to do is we're going to create the correlation, which is equals CORREL. It pops up right here. And we want to select two data ranges. So first one, comma. Don't forget the comma. Second column, press enter. Yeah, we're good. 0.9999. Okay, so definitely greater than 0.997. So no, answer part A, it does not need to be done again. We're good. So what is the equation least squared for predicting the absorbance? And then predict for 500 milligrams. Now, being that we are really high regression, this should be pretty accurate. Okay, because that right there is really high, this should be pretty accurate. So I'm going to make the, again, do your scatter plot. So insert chart, inserts the scatter plot, and ooh, that does not insert a scatter plot. See what it did? Line chart. I don't want a line chart. I want a scatter plot. So scatter plot, which again does form a pretty solid line, even though they're a little bit off here and I think a little bit off here. All right. So let's see here. We go down to customize and then series, trend line, and then show equation. Use label, use equation. So that's my equation. I'll write this on here. The equation is y hat is equal to 1.66 plus 0.113 times x. All right, so that's what I needed. I'll draw it over here because I forgot that's where my writing was. So the equation is y hat equals 1.66 plus 0.113 times x. So that's your equation. That's part A. I'm sorry, part B. And then predict for 500. So y hat is equal to 1.66 plus 0.113. All right. 500. Okay. So what do you expect absorbance to be? Again, basically place in your calculator. Based on your plot and your correlation, do you expect? Yes, because this was really close to 1, it should be really accurate. Okay. How many questions I have you guys doing? Let me check. Because I forgot. Let's see here. Homework. 25. Okay, not too many. Oh, so you have to do all of them though. Okay. So I guess I'm doing the odds. You guys can do the evens. All right. But they kind of all ask the similar questions again. So let me clear this. So, is wine good for your heart? Table 4.3, page 101 gives data on wine consumption and heart disease. Correlation of these variables is negative 0.843. What does negative correlation say about the wine consumption and heart disease deaths? What about the percent of variation among countries in heart disease death rates is explained by a straight line of blah, 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 blah. Okay. So, part A. Now, part A is saying, what does a negative correlation say about what? You don't even have to do anything yet for part A, just explain what this means. So, what does this mean? What does a negative correlation mean? I'm going to move this over here so I can draw. All right. So, what does a negative correlation mean? So, what this correlation means is, so part A, there is a negative relationship between wine consumption and heart disease. Which means it seems that wine consumption does have a relationship, a negative relationship. So as more wine you drink, the less indication of heart disease, okay? Again, you can have correlation, doesn't prove causation, guys, so don't go thinking I'm telling you to drink wine, okay? Because one, you're minors. You should be doing that anyway. So, now what is the percent of variation? This right here, this question is asking R squared. That's what it's asking for. Just square this in your calculator. Go in your calculator on negative 0.843 squared, and we get 0.71. So about 71% of the decrease in heart disease. And I don't know how to spell so bad. Okay, let me try that again. Where is it? Yeah, disease. Can be explained by the relationship between wine consumption and heart disease. Sorry for my bad handwriting. I am saying this as I'm going, so hopefully you're listening and going, oh, okay. But that's part A. You don't even need to really do anything except grab your calculator. All right, so part B. That's the least square regression line. Is that what I have in my book? Hey, it is. Something's actually correct. Okay. So, use the equation to predict. Oh, just plug in 4. That's all you do. Plug in 4. All right. And then part C, the correlation in A and the slope both are negative. Is it possible for two quantities to have opposite signs? No. It is not possible for them to have opposite signs because the correlation is used to find slope. The correlation is used to find slope. So whatever sign the correlation have will always be the sign of slope. Done. All right. So try the other questions. Do the best you can. We're going to move on to chapter 9 on Monday. Okay. Yes, we're skipping a few chapters, and that's fine because I can do what I want. All right. So where are we at? Stop.